Hi there, this is a recording for cisp310, the Tuesday-Thursday class, about question number 5 of the final exam. So this is question number 5, and the code is already at the upper right-hand corner. So let's go ahead and work on this one. So this particular question there are a few key pieces to this particular question. One has to do with the use of a local variable. So we have to know where to find the items on the stack when we have a parameter, a hidden return address, which we cannot see from the C code, and a local variable here. And then the parameter itself is a pointer, and we need to dereference that pointer inside the code. And there's the dereferencing of the pointer itself, and also the dereferencing of where that point, 1 byte past where that pointer points. And then there's some comparison here, okay? And obviously there's some optimization that can be done because we are using the same thing over and over again. The local variable needs to be incremented or decremented depending on the result of the comparison. And then there's a return value. So all of those things are important when I'm grading this. And it is absolutely right that I forgot about one thing. I forgot to increment P1 in this code. So when we actually run it, it will either return right away when P1 is, or P1 plus 1 is pointing to something that is null, or it's going to be stuck in an infinite loop. But that's okay, because your job is just to translate that into C code, but not to run it. All right. Oh, and also when we compare using these, you can see that P1 is a pointer to signed 8-bit integers, so we have to remember to use the L flag instead of the C flag. So those are all the important stuff. All right, well, with that in mind, let's go ahead and work on this. So we'll start with the usual, okay, naming the subroutine first. I notice in some submissions, when you guys turn in your program, there's no label for the subroutine itself. So the question is, without that, how is the caller going to know how to call the subroutine? All right, so after we allocate for the local variable x, it's going to be that will be where the pointer points to, where the stack pointer points to is going to be x, and then there will be the return address on top of that, and then there will be parameter P1 on top of that. So if I want to use labels for this code, then we can have x being defined to be 0, return address to be x1 plus, and then we'll have P1 being return address 1 plus. So labels are really handy to use, although because of my bug in this program, if someone optimizes everything out and basically store whatever P1 points to and whatever P1 plus 1 points to into 2 separate registers, and it's going to be okay. So let's go ahead and get started here. We have to first start with decrement D to allocate for local variable x, and then we have a while loop here. We have a x initialized to 0, so let's do that first. There's no need to do an LDI and stuff like that, so a single store. I need to put the 0 into somewhere first. Okay, so LDI A with 0 and then STDA is fine, okay, instead of the full-blown method of calculating the address of local variable x. It doesn't really save that much instruction. It saves like one single instruction, so it's not really that big of a deal. All right, so let's move on to the while loop. So every while loop starts with a while begin, or whatever label you want to use, and then we have to look at the condition. So this is where things can get a little bit handy because of the bug that I put into here, because P1 never changes. So now we can do a LDI AP1 add AD. So now we have the address of P1 LDAA. Now we have P1 itself. Okay, so the other dereferencing, I don't want to mess up A, so I'm going to LDB A. This is basically whatever P1 points to. Then I'll increment A, and then LDC A. Oh, okay, bad penmanship here. LDC A. So C is now whatever is one byte past where P1 points to. So that can become handy because I can now do a logical AND. So remember, this is a logical AND, not a bitwise AND. So the use of the AND instruction is not going to be useful here. So what we'll do is we'll say AND BB JZI to while AND, and then we'll do an AND CC JZI to while AND as well. In other words, if at least one of them is 0, we're getting out of here. They need to be both non-zeros in order to enter the body of the loop. So once we get to the end of the loop, we have an unconditional branch back to the beginning of the loop. And then we have while AND. Okay, let's move it down a little bit. So we have while AND here. Now we can focus on the return code. If you don't like to waste instructions, once again, register D, the stack pointer, is still pointing to the local variable x. So you can just do LDAD to specify the return value. Increment D to deallocate the local variable. And then we do another LD, but this time we have to use a different register. BD, this is our return address. Increment D again to deallocate it, and then the JMPB to go back to the caller. So that's kind of the outermost part of the code. And in terms of line numbers, this is line 5. All of this stuff here, it's kind of the condition part of the loop, which is line 6. And then this part here is the return x part, which is line 17. And this part here is, you can call it line 17, you can call it line 18, doesn't really matter. So I'll take both. All right, so now in between these two branches, we have the body of the loop. The body of the loop has a conditional statement, so we have to evaluate, we have to do the compare first. So this is where we need to actually do some compare. Now, because I already know that register B is whatever P1 points to, register C is whatever P1 plus 1 points to, I can now just compare those two, CMP, BC. And in this case, we have in C, it is kind of complex because we can't look at different flags in order to do the branching. So that's why line 8 and line 12, they have to compare again, even though the result is already set by the first comparison. As you can hear, I'm drinking my coffee here. All right, so we can do something like this. Okay, JLI if B is less than C, or with if whatever P1 points to is less than whatever P1 plus 1 points to, then we go to the first then. Okay, so this is where we go to the then statement, and then otherwise we go to check again. Okay, so check again. So the then statement is here, and we got some stuff to do. I think we got enough space, so I might as well just do it here. We have to increment x. X is the local variable. It is still pointed to by the stack pointer, so we can just do a LD AD increment in this case, increment A, and then we do a STD A, and then we have to remember to do a JMPI to the end of the conditional statement. Okay, my hand keeps touching outside of this particular window because it's not my actual entire screen. Okay, so we have check again. Unlike the C code on line 12, we don't really have to do another CMP because we just need to look at the other flags of the CMP that's already done. So this time we can say JZI to end if. Okay, so now when we get to here, you can basically, you know how we can get here. First of all, the L flag is a 0. Second, we know the Z flag is also a 0. In other words, it's not less than, it's not the same, it has to be greater than, which is exactly what we want on line 12. So now we have to decrement decrement X. So once again, LD, AD, decrement A, store it back to wherever D points to, and then we're done. With this one, we don't need to jump around because there are no additional branches after this, so we can just kind of fall through to the end if label, which is right here. And that concludes the conditional statement in the inside. So this part here is the conditional statement inside the while statement. So if I have to label the line numbers, this is pretty much line 8. And then we have this part here is line 10. This part here is kind of interesting. Even though it's just one single instruction, it's doing what line 12 is doing because it's still using the same flags that were updated by the compare instruction all the way up here. And then this part here is basically line 14. And that's it. That's the entire program. So let's go ahead and think about, how I am going to grade this particular question. All the important pieces. So I'll point out the important pieces, maybe using a highlighter. There we go. All right. So the important pieces include the allocation and the deallocation of the local variable. I need to know that you know how to access the items on the stack. So this is one, getting to this is one, those are both local variable X. And then local variable P is done by this block of code here. So that's accessing local variable P. And then we have some additional ones, for accessing not local variable P1, that's a parameter. But when we refer to local variable X, there are some additional pieces here. That's also local variable x, that's also local variable x. So those are some of the important pieces. So let's point out some of the really important pieces. The really important piece is we need double dereference to get to the things that we want to actually use for comparison. This is one, and this is the other one. The increment A before LDCA is kind of important because if the sequence of the increment is not done correctly, or you're using the wrong register to do this, the end result is the code would not be looking at the content pointed to by p plus 1. So there are variations of this code that are definitely incorrect. All right, so, and then in terms of control structure, the while loop control structure has this part, and also everything in between here. Some people, I'm just guessing, I haven't seen the answers yet, but some people might use the bitwise AND, the AND instruction, but ending B and C instead. That is not going to work because that's a bitwise AND, so that would not receive any points. So it has to be done kind of like this. And then there's also the control structure of the conditional statement. So with the conditional statement, what I'll be looking at is the less than is going to increment local variable x, and then skipping around when they're equal is important. That's actually a part of the loop here. This is also important to skip around the second branch of the multi-branch conditional statement. So those are the things that I'll be looking for. That also makes this kind of important. So basically I'll be looking at all of the code actually. The only thing that is not really highlighted here is how we initialize a with 0 so that we can put it into local variable x, and the usual typical return instructions at the very end of a subroutine. One more thing. This relates to how we access the items on the stack, and so I'm going to use orange for that purpose. So this part is, it may be explicit, may not be explicit depending on how you code your subroutine, but I can probably tell whether you know the correct order of accessing items on the stack by reading your code. But the implication here is I need to know that you know how things are organized on the stack. All right, so I think this is our last question. I will go ahead and grade it, and that should be it for the final exam for this class. Well, other than also grading the homework assignments.